Let's continue to the last presentation of the day. The title is Research Challenges in Artificial Intelligence for Network Management by Dr. Jefferson Nouri, who is joining us from Porto Alegre, Brazil. Dr. Nouri is an associate professor with the Institute of Informatics at the Federal University of Rio Grande do Sul in Brazil. He has experience in computer networking, network management environments, and network measurements. So please, let's receive Dr. Jefferson now. Professor Jefferson, can you hear us?
See the presentation?
Not yet.
No.
No, still no.
What happened? Let's see. I think that I managed to do that.
And now you're sharing your screen.
Okay. So
But
let's see.
Yeah, that's okay. Can you hear us, Professor Jefferson? I think that you are having trouble with the connection. You are muted again.
I don't know what's happening. Okay. Can you see the presentation?
Yeah. We're watching the slides, and now it's loading the presentation.
Okay. So can I start?
But we don't see still the presentation. It's like the black screen
What?
that says loading, just says loading, doesn't say anything else.
I don't know what's happening. Nothing.
No, still. But I can you confirm that, Sophia? Maybe it's my connection, or were you watching, Sophia?
No, the slides are low.
Okay.
What about it? Can you see the presentation?
No, Professor. It's still there, like the black screen when it starts loading the presentation, but it's there. It just says carregando.
Let me try again. Let's see.
No, Professor. Still, it says now that you are starting to share content. Now I can see your screen. Yes.
Okay. Can you see the slides?
Yes, the slides in this right now we can see that. Yes.
Okay, let me try to present again. Otherwise, I will just use this view.
Okay, Professor.
Can you see the presentation?
Yes, we can.
Okay. So, good afternoon. And first of all, I would like to thank you for the invitation for this webinar. So the thing on my presentation will be research challenges for artificial intelligence for network management. And I also want to thank for presenting me before. My name is Jefferson, and I would like to say that if someone wants to make a question, it's not necessary to wait for of the presentation, so just start talking and we can discuss right on the spot. Okay, so this is the outline of the presentation. I'm going through the introduction, just a few contexts for this topic. I'm going to talk about difficult problems in network management, and after that, the artificial intelligence network management. I will discuss some to employ artificial intelligence techniques in network management. And then I will present some research challenges, and then I finish with an outlook for this topic. Okay. So, network landscape is profound changes over the next decade. So, we expect to have different network services available for the users and developers, and this will lead to new applications. So, for example, there is haptic applications that will require, which people commonly call tactile internet. And there is also this holographic type communications, something like which you were used to watching in some movies like Star Wars and this kind of scientific fiction. And to a need for high degrees of precision on the network. And for example, these in terms of the end-to-end level objectives. So it will be necessary to have tighter control over the network, and obviously this will lead to profound implications on network and service management. Are you able to hear me? Is that okay?
Yes, Professor.
Okay, thank you. So, regarding the network management area, we have at least something like 40 years, 45 years of experience. Not me, but the area. So we have a set of well-established network management algorithms and methods. So, for example, when I start a computer network class, the first day of the class, I used to ask people, do you know some kind of a network management tool or technique or something? And the students used to say, no, I don't, or I've heard some info about network management and kind of stuff. But we have, for example, when I ask them, oh, do you know, for example, the SNMP? Most students, at least they heard about SNMP. So then I go one step further and say, do you know ping? And probably almost every student in a computer network class heard about ping. So there is a set of well-established network management algorithms, techniques, tools, methods. And these techniques, we can discuss the quality or the weakness of the strengths of the weakness of these methods, but they have a clear they have clear performance guarantees and troubleshooting mechanisms. So when you provide a network today, when you provide a network, you can expect that you can use ping, you can use SNMP, maybe netconf. So have a set of these well-established tools. But if you want to, to go further, for example, proposing the use of new technology, new approach, at least to meet the existing, the quality, the features of the existing ones. So this is a very important point. It's necessary to have at least the same quality of the existing tools. And this problem is usually addressed in the academia by management community. So I just pointed out some of the venues for this. So the IEEE, NOM, CNSM, which are conferences that publish network management works. And there is also the JNSM and IJNM, which are journals that publish network management works. So we have a well-established area, years of experience, tools. So the question that we can make is, okay, we have all this work on network management, but there are difficult problems in network management today. So the fact is that there are many difficult problems in network management. And for these problems, we don't have good solutions. And in other problems, we have solutions which have significant limitations and constraints. So for example, there are lots of problems in network management. They are related to allocation of resources. These problems, lots of it, are NP hard or NP complete. Okay, so we as computer science professors or professionals know that if you are in NP, you have a lot of problems regarding scalability. Besides that, there are problems that they need very short control loops, because we need rapid decisions and the ability to adapt to different situations and contexts. So we can say that we have difficult problems, and other problems are not that difficult, but the solutions have to be very quick. So what you can do about these difficult problems? The solutions are heuristics that may not yield optimal results, which is the definition of heuristic, and also algorithms that run into issues with scalability. So we have a solution, but we know that this solution scales to a defined level, and after that we don't have a good solution for this. This is because of the exponential search space. Besides that, there are many problems that do not avoid humans in the loop. So, for example, for some problems, it's that you have trouble tickets, and then you have to use some kind of a human to sort it out, how to address these trouble tickets. It is necessary humans to perform the planning of new servers. And so when you have humans in the loop, we know that you have operational bottlenecks. It's expensive to use people to perform some jobs, and also it's error prone. So I'm going to list some examples of difficult problems in network management, and I'm not going through these problems, but just to make sure that you understand that there are lots of problems, of difficult problems in network management. So, for example, the optimization of allocation of resources, the computation of optimal paths, the troubleshooting and diagnostics, forecasting and anticipation of traffic, preventing production traffic leakage, recognition of novel attack vectors, and I think that maybe some of you are thinking, okay, but for this specific problem, I know a solution. I know that there is a solution for this. So when I'm saying that these problems are difficult, I'm not saying that there is no solution. It's important to remember that. But the solutions are not optimal, or they are not practical, or they have some significant constraints to address. Okay, so I'm going to the topic of the talk: artificial intelligence in network management. So the hypothesis here is that artificial intelligence, or AI, may help regarding these difficult problems. So at this point, it's kind of a magic statement. I'm just saying, okay, we have difficult problems. Maybe these problems can be addressed using artificial intelligence. So for now, let's just accept that. Using artificial intelligence, we can have novel solutions for these problems. Remember that we already have some solutions for these problems. So what we want is better solutions for these problems, okay? And these solutions, they have to consider different requirements, and these requirements are specific to each scenario. So for example, there are problems that consider real-time operations. They are problems that consider multi-players, multi-vendors, multi-autonomous systems, and this kind of stuff. These scenarios consider different levels of resilience, and also about the size, the scalability of these problems is very different. It's very different. Sorry. Also, we are considering different layers. So these artificial intelligence solutions can work from the application layer to the packet processor. So going through 1 to 7 in the Aussie network model. So, and also I'm not saying directly, but we also can consider some cross-layer solutions in this context. And the thing is that maybe someone is thinking right now, okay, this is right, this is cool. So we can start to use artificial intelligence network management, but in fact, this is used since the 90s. So what I'm saying is that for more than 30 years, artificial intelligence is used in network management. So at some point of my presentation, I'm going to ask, okay, so what's the point of saying this in 2020? Okay. So one of the things of using artificial intelligence in network management is the ability to derive plans of actions and solutions. So we will produce a desired outcome, to reason about it, and controlling trade-offs. And this is very difficult to do. Okay. The requirements at this point are to have a plan of action. So the artificial intelligence solution must present a plan of action, a matrix of resource allocations, the possible solutions, and the best outcome. And saying this seems maybe easy, but it's very difficult to have this kind of points in order to derive a good plan of action and a solution for a difficult problem in network management. Okay, so now I'm going to talk about 3 approaches of using AI in network management. I'm not claiming that they are the only ones, the best ones, or something like this, but just want to point out 3 approaches that are strictly related to network management, AI network management, and I'm going to talk a little about these approaches, and also I want to talk with you about it. We can discuss. We can, you can talk more about this approach. So the first one is intent-based networking, maybe the hottest one at this point. Then the integration with network automation approach, which is very important. And in the end, the autonomic network management, which is an approach that had a lot of momentum in the past, and right now it's more in like in a, how can I say, in a gray area. So first, the intent-based network management, or the intent-based management, it's known by the initials IBN, sorry. And the intent is something like this. I just want to say to the network what the network has to look like. So I could imagine some kind of best outcome of the network, and then I will say this to the network, say, I want you to work in the best way possible, considering some kind of properties, and then the network has to figure out how to meet my desire. this is maybe the ultimate goal of intent-based management. So for people which is more experienced in network management, we used to know this kind of stuff like declarative policy or declarative policies. So a policy, it's kind of a set of rules that you present to the network. Maybe you can say some kind of traffic is not allowed after 6 o'clock p.m. or something like this. So you can say, and when you go up in the abstraction for this kind of policy, you at some point start to say that this is an intent. And this is tightly coupled with service models, orchestration, and at the lowest level with the configuration of the network. So this is a very important network management concept right now. There are lots of people working on intents and lots of PhDs, and the vendors are also working towards this goal. Okay, so and where AI can help regarding intents. So, for example, to have intents, we need an automated annotation of these intents in order to extract them, the annotations. For example, to understand what are the management entities. I want to know what device, what's the server, what's the difference between a end host and a server. In order to do this in an automated way, we probably need some kind of AI. So for example, when I say, I want to the server to stop accepting some kind of request after 6 o'clock p.m. Okay, so it's necessary to figure out what is the server, for example, in some network. So we need AI to do that. Beside that, we have this what we're looking for at this point is we use this term named entity recognition. So for example, I use the example server, but we can have, for example, my computer, which is what's my computer. It's something that network has route, or I can say I want to my daughter's computer not to access some kind of for example, of social media or something like this. So it's necessary to understand what are these entities. So it's necessary, which is called named entity recognition, and this is done using NLP or natural language processing, which leads to AI, some kind of machine learning to be at this point. So this is something that is necessary, and it's necessary to have AI in order to bring more powerful intent-based management. Oh, as I was saying, so it's necessary to learn network operations to perform intent management. Will be done using machine learning. There are lots of research on this topic in order to generate intents and these high-level policies. So the ultimate goal is to have automation or an automated network, and this must be performed in an incremental way. So when we have this, for example, at first point, my first example was the server, the traffic of this network must stop or must decrease by a percentage at 6 o'clock p.m. So this is maybe it's not, this is something that right now it's difficult. So maybe we can have, less abstract intent. Maybe we can say the server with IP address must stop working at 6 o'clock p.m. So at that point, we can understand that server and IP address, they have this some kind of relation, and maybe the network management software can ask the user, okay, when you say server, you are referring this IP address, then the user can say yes, and then the network operation, the network management software can learn this and start to build some kind of a knowledge base or something like this. So an incremental way, probably it's necessary to have intended base management. The second approach, integration with network automation. In this topic, we are talking about automating the configuring, managing, testing, deploying, operating a network. There are lots of vendors. I got this definition from Cisco, but maybe it's it's difficult to say. But I think that every vendor, every network vendor that has some kind of an integration with network automation. There are lots of tools. So there's NetConf, there's Ansible, Napalm, and others tools in order to provide network automation. Also, the ES as a standardization Europe has this zero-touch network and service, or ZSM, which is an initiative in order some kind of a standards for network automation. So here, what they want is to address the problem which is brought from the overall complexity, which is resulting of the transformation of network. And this is something that it's interesting because when we start to having all programmable interfaces like SDN and NFV, the first thing that we used to say for other people is that, oh, now it will be a lot easier to manage, to control my network because it has this programmable interface. The fact is that this if you have a lot of interface, in fact, it's more difficult to understand and to control the network. So it's necessary to have some kind of a framework to put some standards on that. So in this image, I bring this image in order to show that in different levels. If I think you can see on this image, there is intelligence. So there is E2E, end-to-end intelligence, there's domain intelligence, and so forth. So the question is to have network automation or to fulfill the goals of network automation, it's necessary to have intelligence at different levels of network. This is something very important and something is researched right now and was in the last maybe 10, 15 years, and is also that in something that probably will remain important research topic on the next 10 years. Okay, so to have full end-to-end automation of network service management, this is necessary to have digital service provider. So I want to be a provider of maybe NFV, security NFV. So it's necessary to have full end-to-end automation to do that. Because if you need some kind of a human to perform operations, you are not a digital service provider. So this is something that it's really importance. Okay, so the requirement here is to have an horizontal and vertical end-to-end architecture framework. This is something is zero-touch management and service management to provide. This framework is designed for closed-loop automation, data and AI models. So at this point, for these guys, it's clear that, okay, we have this framework to have some kind of AI and ML in order to provide. Okay, and the last approach that I'm going to talk today, it's autonomic network management, and this come from the network, and this come from autonomic systems. So for this concept, you have a minimum set of properties, and these properties are we need to be automatic, or in other words, to have self-control functions and operations. We need to be adaptive, so we need to have changes in configuration states and functions, and we have to be aware. So an autonomic system can monitor its operational system. So if you apply these properties for a system, you have an autonomic system. If you apply these properties for a network, you have an autonomic networking. And if you apply this to complete network lifecycle, considering installation, commissioning, and operating in terms of network management, you have autonomic network management. So this is an image that shows different areas, different disciplines, different theories that can be used in order to provide autonomic network management. So you can see that artificial intelligence is here, policy, and by policy at this point you can read intent, machine learning, and control theory, bio-inspired game theory, and other kinds of stuff. So autonomic network management is kind of an umbrella term for different kinds of operations in the network. So in the last stage for autonomic network management, we have something like this, like a closed loop for the network. So you have the actual versus the desired state evaluation decision making. So regarding decision, there is a new configuration for the management resource, there is some gathering, and then the maintenance loop, and this will go forever. So this is called an autonomic management. And this is just, one of the first sketches of an autonomic manager. And this is something that has been investigated for, let's see, 15 years, right? And it's kind of scary to think about it, because I performed my master's and my PhD in autonomic network management, and to think that we have right now 15 years of research on this, it's kind of scary. And there are some good results, and it's kind of an interesting approach in order to provide to use AI in network management. I'm going to the end of my presentation. There are some research challenges, and the very first point of this topic is to present research challenges, and this is on the title of my presentation. So first, there is a problem on the explainability of network AI products. A common issue across AI and machine learning, especially machine learning applications, they are black box. So we have this kind of a result of outcome that comes from the black box, but we don't understand why the choices were made. We don't know that. We just say, okay, that's it. You have to use this configuration. You have to turn the knobs like this, but we don't know why. And in many areas, this is not a problem. We can just accept that, and that's okay. But regarding a field that we have a lot of well-established tools, well-established techniques, well-established approach to have this, it's kind of a difficult. So if you say for a network administrator, okay, we're going to use this box on your network, and the box will say what you have to do, and that is it. This is something that doesn't work. Probably you say, okay, I prefer to trust my feelings, to use my knowledge instead of just reading what comes from a black box. So this is something that doesn't work. The second research challenge for AI in network management is the lack of real-world networking data sets. And this is a common issue across networking research. So, for example, there are lots of research areas that they have data sets that can use to train, to baseline, So for example, computer graphics area, they have different kinds of images and videos that are baselines for their research that they can use to train, okay? Several algorithms especially from machine learning, they need a set, and mostly they need sets with annotations in order to train the algorithm and to provide some output. So it's necessary to have that for networking. Okay, so what's a problem here? There are lots of questions about privacy and anonymization. So if I provide a networking data set from my network, probably I will expose the traffic from my users, have some of anonymization in order to protect the user, to protect the network infrastructure, because if my data set has information on, for example, on the IP address or the routing of the network, it's possible that some attacker can use this information in order to attack the network. So this kind of a problem, it's necessary to clean the data before provide a computer set. So this is right now the answer from the network management area for this is several hackathons, contests, for people that provide some kind of a working networking data set. And the first challenge that I'm going to present today is the need for world-class experience. And this is important because we can use this experience to learn lessons. So for example, when there is an inherent error in a recommender system, for example, Netflix, you are watching Netflix, and at some point Netflix suggests a movie to you that you don't like. So you can say, okay, I don't like this movie, so bring me another one. And then Netflix can provide another suggestion for you, but this error, it's kind of you can say, okay, Netflix got me wrong because of some edit that I performed, but it's not my taste for movies. Okay, but imagine network management. At some point, the network management software suggests you some configuration on the network that is terrible, that you know that this configuration doesn't work. So I don't want, but how can I trust the network management software to bring another configuration if the first one was so wrong? This is something that it's very difficult to manage. And I mean, even psychologically. Okay, so for a long time, we will have human in the loop. So the question that we can say is there a man on the wheel? So at some point, that, for example, the network management software states that it's necessary to shut down the network. Okay, so what are we going to do? We're going to call some network administrator, and how we're going to pass the control of network. At this point, maybe it was already controlled by the network management software. So how can we say, okay, you can get the control network and then you can do it right? How can we do that? It's difficult to pass the control for a person, for a human, if you are running by a computer. And finally, there's this scalability problem. So when you have AI solutions for network management, these solutions must be prepared, for example, for large operators, for people that have millions of devices on the network. Because otherwise, we don't need AI. So this is kind of, it's necessary to have this, but it's difficult to test this. So we're in the middle of I don't want to say deadlock, but something like this. It's necessary to test on a huge network, but the huge networks don't want to be tested. So it's kind of a area that we need some initiatives at least. So I'm finishing my presentation. How to look at AI for network management. There are new application areas, and I'm going to stress that high precision apps such as holographic type communications, they need artificial intelligence for network. It's necessary. As we go forward, we will have highly virtualized programmable infrastructures in terms of 5G, IoT, smart city, smart factory, smart industry, smart health, and this kind of stuff. So it's necessary to have some kind of AI for the network considering these areas of application. Also, it's necessary to have a better link with real operations. So it's necessary to be close to the operators organization as Nanog, LACNOG, RIPE, guys, because they have better insights on the infrastructure specificities. So they can say, okay, for this kind of a structure, of infrastructure, I know that this kind of solution will work. So you have to hear this and try to put this on the knowledge base of an AI system. And this is something that it's not easy. It's difficult to get these people, and also difficult to model their knowledge for an AI system. So, and this is my last slide. What's the vision for the future, considering this self-driven network? So we're talking about self-driven vehicles, cars today. So at some point we will have self-driven network. So this is an autonomous network programmed to carry out station. I want to do the network behave like this, and the network will figure out how to do that. And then we will eliminate complex programming and management tasks that are required today, and they are costly, they are error prone, and they are not scalable. The network performance issues before users are affected. So we are trying to avoid the users have to complain about the network, so we do something about it. And this is something that is very important, to provide the best experience for the user before he complains about it. And finally, the elimination of burdensome operational tasks. So if you can avoid the use of humans on the operation tasks, we can free the users. And at this point, I'm saying users as network administrators. We can free network administrators to more valuable tasks, such as, for example, high-level planning of the network, and the development of new services, and so forth. So my question is, this can be done without AI? I don't think so. This is the first thing that I would say. I don't think it's possible to have a self-driven network or self-driving network without AI. And at this point, I also want to leave you with this question: what are the reasons for the lack of wide-scale deployment for this artificial intelligence in the network management? So I brought some answers for this question, but I think that's important to think about this question in order to how can I say, to pursue other ideas in network management. And then in this presentation, I'm talking about this considering artificial intelligence. So that's it. I'm going to thank you again for the invitation, and I'm open to questions. I don't know how much time we have, and this is my contact. Feel free to send me email or to ping me at Twitter, and that is it.
Thank you very much, Dr. Nori, for such amazing presentation. Now let's begin with the round of questions. First, the question from Professor Oscar.
Hello, Professor Jefferson.
Hello, Professor Oscar. Okay. There are questions on chat, right?
webinar. The most of the audience or the attendees are undergraduate students. Then, what are the skills that you think that a new engineer or an engineer from this era needs?
Thank you for the question, Professor Oscar. I think that for the new area of how can I say, maybe AI for network management, this kind of stuff, it's necessary to have a good understanding of algorithms, and this is something that usually is taught on a computer in every computer science course. I think that for some time, maybe the networking guys, they got a little away from the algorithms, from the programming side. And with all this programmable, data-driven, virtualized stuff, it's necessary to really understand the algorithms, and even from the basic ones, it's really necessary to have a good understanding of algorithms. It will be necessary to have a good understanding of programming. So this is also necessary, and maybe the manipulation of large data sets. And I can say for sure that if you have these three expertises, probably are a very valuable asset on the market.
Another, how to deal with the lack of data if the network providers don't want to share data. How to deal with that problem?
This is a very difficult problem to deal with. So I think probably the best way to start to bridge this gap is to work closely with the organizations of operators, for example, LACNOG or NANOG, or in our case, LACNOG, and RIPE in Europe, and this kind of organization, because since they are closer to the operators, it's easier for them to start the conversation. And at some point, when you have the trust from organizations, from the operators, usually it's necessary to have a well-described plan, especially regarding this privacy and security issues, in order to make them comfortable with the idea of sharing information on traffic. But it's difficult. This is why this is because I put this on like a research challenge, because I know it's difficult to have this information. And for example, in Brazil, we have our research network, which is RNP, and this is the best source we have for data sets, because it's kind of a research oriented network. But to have these data sets from an operator is really hard.
Thank you, Jefferson. Please, Sofia and Felipe, give the the turn to the Professor Juan Felipe Otero, that he's going to perform a question.
Okay, I think that he can unmute himself. I don't know, Sophia. Sophia, can you give permission to Professor Juan Felipe Otero?
You are
Yeah, I think that he's the Professor Juan Felipe.
Can you hear me, Felipe?
Yeah.
Yes.
Okay, perfect.
I already asked the question in the chat, but anyway, I will ask it again.
Okay.
To me, it's sometimes like I have a big doubt between this intent-based management or intent-based networking with the complete and old policy-based network management. So I don't know what's the difference between like intent and policy, or this is just the new way to call the policy-based management when you had a big, like, let's say, high-level policy and you wanted the management plane of the network to translate that policy in configuration and comments to the data plane equipment. So I don't know if it's the same, or in intent-based networking or intent-based management, we are referring more to the one that is completely automated by AI mechanisms.
Okay. Thank you, Professor Botero, for the question. I believe, and what I'm going to say, it's not a consensus on the area, but for me, and I'm saying this like someone that work a lot of time on policy management. Intent is a subset of policy-based network management. And why I'm saying that? Because for me, an intent is a high level policy.
Okay.
So for me, it's this. But I know that there are lots of researchers that they don't agree with this. They say, okay, it's different kind of stuff. Like intent is different of a high level policy. So, but in my opinion, when you ask this, what's the difference? It's very difficult to say that, because when you perform the question, you say use the words a high level policy that provides some kind of a full automation. But for me, there's a continuum from low level policies to high level policy and then to the intent. So for me, it's kind of a subset. But I know that this is not that some researchers do not agree with this.
Great, thanks.
Okay. Angela.
Yeah.
Right, I have a question.
Yes. Hi, Jefferson.
Hi, Angela.
This is Angela. Thank you for your presentation.
Okay.
It's very related with my PhD proposal. I apologize about my English, so I try to pose my question. Okay. You mentioned, can you show please slide, I mean, slide where I think it was slide 15, where when you showed the closed control loop for autonomic networks, please.
Professor Jefferson, you have already the permission to present. So share your screen again, please. Professor Jefferson?
Hi, Professor Jefferson, can you hear us?
Person, are you there?
I already wrote to him to see if maybe he can hear us.
Okay.
Okay.
Yeah, I think he lost the connection.
He lacks the. Yep. Mm.
He's connected again. Can you give some permission to Jefferson again, please, Sophia?
Yeah, I will, but I don't see him.
Uh,
Uh,
it's,
uh,
it's,
I'm talking with him in the WhatsApp. He's trying to reconnect.
okay.
Okay. Mm.
Let's see.
Oh, okay, Sophia, give the permissions to the professor.
Yeah, he has not the permissions.
Yeah,
Okay, the question that Angela raised was, from your point of view, is it an advantage or a disadvantage to include human administrator in the autonomic control loop? And Jefferson is saying uh, it's usually a disadvantage that from the autonomic control loop point of view, the idea is not to consider the human administrator in the process. Okay.
Are you hear me? Hello?
Hello, I'm here. You.
Okay. So if someone has another question, I'm sorry, but I have a problem here.
It's okay, Professor.
Okay,
So,
Jefferson. The question is about the inclusion of the human administrator in the autonomic control loop. What is your point of view?
No, I believe that yeah, I'm just heard the last part of what you are saying, and I agree. Usually, it's a disadvantage to have a human in control loop because uh, the time of for a human to react is usually slower than of the computer. So when you have a human on the loop, you probably are going to talk about a more high level work of the network. So for example, we can talk about for example, the routing protocols. They are development not to rely on the humans, because if we do, the time to add or some fail on the network will be very large. So it's usually best to not have human, and just avoid the human on the control loops of the network, and reserve them for more how can I say, high level operations.
Okay, Jefferson. Thank you.
Okay, thank you for the question.
thank you very much, Professor Jefferson. Thank you, Angela.
Thank you.
So, there are no more questions. Thank you very much again, Professor
Thank
uh,
you.
Jefferson, for joining us and sharing your work and knowledge with us today. We are sincerely grateful to you, and yeah, we know that through Oscar using your email, we can keep in touch with you.
Okay, thank you. Thank you very much. It's a pleasure.
So with this last presentation, we have come to the end of the first edition of .NET, our webinar on latest topics in networking. Thanks to all the attendees and the speakers for making this event successful. We hope you all enjoyed it and that you have learned something new. It has been our honor to share this webinar with you. I don't know if maybe Oscar or Sophia have a few last words.
Okay, thank you, Felipe. Okay, I'm going to say the final words. Okay, first of all, thanks for all the speakers. I think the was very nice, and I want to say thank you for all the attendees. We have around 90 every presentation. That's a great number because this is our webinar. And thank you very much, Felipe, for your support, presenting the speakers and the questions. Thank you very much, Sophia, for organizing the webinar. And okay, for me, it's a pleasure to a lot of attendees in networking talks, and we want to organize another similar webinars. I think only international speakers, but here in Colombia we have important. My idea is organize another webinar with Colombian experts. And okay, thank you very much and see you soon.
Thanks, Professor.
Nothing more. I just want to thank all the undergraduate and graduate students and the professional and technical community. It's been a pleasure to have you, and I think, and I hope this will be the first of many other events. And yeah, I hope that this event will be of profit for you. And thanks to all the speakers.
Thank you, Sophia. And well, let's remind you that the presentation slides of all the speakers are going to be shared with you. We're going to send the slides to your emails as well as the report of the presentation of the day. So thank you very much again and see you soon.